The purpose of a fluid system is to transmit power from one location to another. Fluid power is converted to mechanical power by means of an actuator. Cylinder actuators deliver a linear push-pull motion via a rod and piston within a cylindrical tube. A single-acting cylinder is a cylinder in which the working fluid acts on only one side of the piston. The other side of the cylinder utilizes a mechanical load, springs, compressed air, other cylinders, or the momentum of a flywheel to push the piston back in the other direction. This particular cylinder utilizes a spring on the non-fluid side. A single-acting cylinder produces linear motion in one direction. When a control valve directs fluid through the inlet port into the blind end, pressure builds up and generates a force on the piston. When the pressure buildup is large enough, the piston begins to move, extending the rod. This is called the forward stroke. When a control valve directs fluid out of the port, the fluid pressure is removed. The force of the spring pushes against the piston in the other direction, and the rod returns to the cylinder. This is called the retraction stroke. Single-acting cylinders are most often found in reciprocating engines, pumps, and hydraulic rams. A double-acting cylinder is a cylinder in which fluid acts on both sides of the piston. This type of cylinder can produce linear motion in two directions. A double-acting cylinder has two fluid ports, one on the blind end and one on the rod end. A directional control valve sends fluid through the blind end port while venting fluid out the rod end port back to the tank. Pressure builds up and generates a force on the piston, causing the extension stroke. When the directional control valve is shifted, it sends fluid into the rod end port, out of the blind end port, and back to the tank. Pressure builds up and generates a force on the other side of the piston, causing the retraction stroke. To determine the speed of a piston during extension and retraction, we must first determine the significant working areas. The full piston area is the side of the piston without the rod. This is the area that feels pressure as the piston extends. The next significant working area is called the net area. This area is the size of the full piston area minus the area of the rod. The net area feels pressure when the cylinder retracts. The speed at which the piston extends and retracts is calculated using the volumetric flow rate divided by the area for the incoming fluid. Since each side of the cylinder has a different working area, each side experiences a different speed. Let's assume that the volumetric flow rate is equal for each inlet. Because the rod takes up space within the cylinder, less fluid is required to fill that side. This means that the fluid can fill the rod end side more quickly than it can fill the blind end. Since the rod end side fills with fluid more quickly, the cylinder will always retract faster than it can extend. All the cylinders shown to this point have been single-ended. They have only one working rod. On special cylinders, two rods may be used. These are called double-ended cylinders. They have two rods, both attached to the piston, and each coming through an end cap. Double-ended cylinders work similarly to single-ended, but are used when a constant speed is required for both the extension and retraction strokes. Since the flow rate is the same and the piston areas are the same, the speed for extension and retraction is also the same. Due to their simple design, cylinders are used more often than any other type of actuator for industrial applications. Although their motion is linear, it can be converted to rotary motion by levers, racks, and pinions, or other means, making them one of the most versatile types of actuator.